After the completion of my PhD, I was offered a lectureship in the chemical engineering department at the University of Dhaka. I politely declined the offer of Professor Wilkinson and told him that I must return to my newly liberated country, Bangladesh. Even after returning to Bangladesh, Professor Wilkinson wrote me twice to reconsider the offer, but I did not change my mind to go back to Bradford. Was that decision right? In today's context of Bangladesh, the decision was wrong, as I see Bangladesh being cut by a black hole. In less than a year, I left CSIR to join this university as assistant professor in the month of August 1973. I have been teaching here for almost 35 years, excluding 1 year visiting fellowship at the Institute of Polymer Technology at Dhaka University of Technology, and a 2-year appointment serving Chittagong Urea Fertilizer Limited as design manager. These 3 years taught me how to practice engineering and technology. To join COFL, I had to resign from BUET, and when I returned to BUET in 1985, it was a fresh start, meaning loss of seniority along with other privileges. For all practical purpose, I have become non-existent in BUET's hierarchy. This has sometimes hurt me, but it has never stood in my way for being loyal to my students, BUET, society, and motherland Bangladesh. Experience as a teacher. Being a teacher at BUET, I am fortunate to work and learn with the students who are intelligent, bright, and smart. The greatest resource of mine was my students, especially those who worked with me for their thesis projects designs. While the students worked on completing the requirements of academic program, I looked for understanding the underlying principles, why and how things work, why they do not work. All my students have been assigned experimental projects that would require designing, building, and operation of a system. My emphasis and objectives have been to experience the system in operation and learn the limitations. While with the design projects, the students were assigned to design process plants about which I had prior understanding of the plants are in operation in Bangladesh. From my student days, I wanted to be a practicing engineer. I have a great knack for process development and process design. Over the years since 1973, I have been in close touch with ammonia, urea, sulfuric acid, phosphatic fertilizer, petroleum refinery, natural gas processing, pulp and paper, sugar and distillery, edible oil, fine chemical industries of Bangladesh. Being the design manager for 2 years of COFL for 2 years from 1983 to 1985, I learned a little about process design and project implementation. I participated in a number of troubleshooting efforts in different chemical plants. Some of these works involved common sense, innovative ideas, and using of the underlying principles of engineering fundamentals. Plant managers accepted the recommendation and implemented them, negating their own conclusions and work plans. I am citing here 2 examples of my engineering decision while working with COFL as design manager. The general contractor Toyo proposed to build a 3 km long covered urea bulk conveyor gallery 90 meters above the ground. The 3 km long gallery with 3 meter by 3 meter continuous covered housing with a conveyor and estimating system had to be designed to withstand a wind speed of 150 miles an hour plus gusts. Toyo was told to keep the height 3 meters instead of 19 meters, as it could not provide any justification to make it 19 meters. It resulted in a large saving for steel structure, support and foundation. It also improved safety. You can have a look at it. 3 kilometers. The next example, the urea unit had an evaporation system to concentrate urea solution from 87.5% BUET to 99.5% prior to drilling. When Prof submitted the design for the evaporation system, it based its heat load by assuming the inlet concentration of 82.5% instead of 87.5%. This meant a larger heat load requiring larger heat transfer area. I told Toyon that at least 30% of the evaporator tubes calculated based on heat load would have to be plugged when commissioned. CFM management and Toyo insisted on for having a larger evaporator, overruling my review on the ground that the oversized equipment would be good for the plant. Alas, when the urea plant was commissioned, Toyo encountered solid urea depositing inside the tube, and it plugged about 30% of the evaporator tube. If you visit CFM, you will be pleased to find that my words were not wrong. An example of common sense application based on fundamental principles was the pollution control of sulfur dioxide in the state of chrome sulfate plant at water chemicals. A cooler was installed to absorb the sulfur dioxide by water condensate of the saturated state gas coming out at 80 degrees centigrade. The solution was based on the knowledge derived from a psychometric chart for water and air and solubility of sulfur dioxide in water. An example of innovative ideas was to ascertain the activity of catalyst in the high temperature shift converter of Dhaka Urea Fertilizer Limited by measuring the converter surface temperature from outside axially at different radial position when all the thermocouples inside the reactor indicated the same temperature for all positions. Based on this measured surface temperatures, the plant managers were advised to continue the operation for the next 8 months until the plant overhauling would be undertaken. The converter functioned satisfactorily up to overhauling. With my colleagues, I participated in the commissioning of a liquid sugar plant built by a French company with French process technology. And if there was one of my colleagues there. A sodium carboxyl methyl cellulose plant supplied by Indian supplier, a liquid detergent plant supplied by Indian supplier. For all three plants, laboratory studies of the process involving all the steps were carried out in the department to experience the process, understand the process parameters, and to write the operating instruction. Plant equipment and machineries were installed under our supervision for the sodium carboxyl methyl cellulose plant and liquid detergent plant. A technical audit of 6 ammonia-urea complexes under BCIC was carried out during 2000 and 2001. It was a challenging one and a good opportunity to learn the inside of this plant. This was a multidisciplinary teamwork, and Professor Mahmood has talked about it while he was introducing me. So you can see all the 6 participants that we audited. I had the opportunity to investigate into of urea fertilizer factory corruption that took place in 1974 and 1991. These were catastrophic accidents leading to the loss of life, property, and production. This is 1974 experiment of ammonia control room. In one case, it was a design fault which allowed air to flush the natural gas filter, and in other case, it was negligence and a contract violation of the general contractor. For both cases, Toyo was responsible. During the period 1992 and 95, I was assigned by the then chairman of BCSN, Dr. Jaman, to design, construct and operation of pilot plants to demonstrate the operability and viability of 10 selected processes developed by BCSIR. 10 separate pilot plants were built in the pilot plant section of BCSIR. This was an interesting experience for learning how issues and steps often missed during the laboratory skill work can undermine operating of pilot